has anyone here heard of Portainer before? Do you know what oh, everybody, look at that. Well, almost. You have to forgive me, because if I look through my glasses, I can't see you, but if I take them off, I can't see this. So you're going to have to, I'm just looking at a blur here. So for those of you that are not familiar or may know Portainer for what we were, we're actually a brand and a product that's 8 years old. Back in 2016 is when the first version of Portainer came about. I'm Neil, the CEO and co-founder of Portainer, so it was my crazy idea to create this thing, and have been seeing it come to fruition over all these years. Portainer initially started out life as a Docker UI, and that's how it got most of its fame and early adoption. Right now, it's had about 4 billion downloads of the product throughout its life. At any one month, there's over 1 million people log into a Portainer instance somewhere in the world and do something. Pretty much every country you can possibly imagine, our analytics tells us that we use. So it's been a bit of a runaway success as an open source project. And we started to commercialize it and have this commercial variant Portainer Business about 3 years ago. Around the same time, we transitioned Portainer from being a Docker UI to being a multi-cluster universal container management platform designed to sit on top of any type of container runtime, Docker, Docker Swarm, Kubernetes, Nomad for a while, but that didn't last very long. Anywhere on my laptop, in the cloud, in the data center, at the edge. So if you have an application that runs in containers, we can help you deploy it. We like to have the user of Portainer basically define their own journey. So what we find is that in any type of organization, there is a vast array of skill differentials between those that are just getting first hands-on experience with containers through to those that are absolute experts and know the ins and outs and are a Kubestronaut. So there's a big extreme here. And so we wanted you to, like those old books where you kind of choose your own adventure, same kind of thing with Portainer. So Portainer at the very left-hand side can give you a very, very guided assistance. So it can have no code, no YAML, no Kubernetes experience deploying any kind of Kubernetes application by someone who really has no idea what they're doing in Kubernetes, all the way through to the other extreme where it's 100% GitOps, pipelines, and full automation. So you can choose, and that decision is made by each individual user of the product, unless, of course, an admin says, no, I want to enforce code-only deployments, and then you can set that and then have the two. Now, why am I here talking to you today? So as you heard at the keynote, we have come up with a partnership with Cedero to help bring Portainer to their customer base. And their customer base and our customer base are quite similar in that we want, or our customers want, an end-to-end solution stack for running containers, right? So they want a single vendor, single throat to choke that says, how do I get a container platform, Kubernetes? How do I configure it? So create, configure, and consume. How do I consume it? So how do I do all three of these things from one vendor? OpenStack is famous for that. OpenStack is, again, soup to nuts, single tool to deploy and manage everything. And both of our two companies, Cedero and Portainer, had an area that was lacking. We lacked the orchestrator, the actual creation side in our product, and Cedero lacked the configuration and consumption side in Omni and Talos. So together we now have an integrated solution, which is fundamentally a drop-in replacement for OpenShift, Spectra Cloud, those other type of full suite applications. So what we have I'm going to show you this now live. We have a version of Portainer that communicates to Omni and will allow you to spin up and manage Talos Kubernetes clusters without you ever having to actually physically be on the machines, without you necessarily needing to know how to write the YAML configuration that underpins a Talos config, without you needing to use Talos CTL. So you can do it all with Portainer. You can provision a cluster, you can scale a cluster, upgrade a cluster, and deploy your first GitOps pipeline all in a very, very short space of time. So I'm going to show you this live. Feel free to interject and ask me questions as I go. Don't wait to the end. There are elements through the demo that take a little long to complete because this is real life and it takes a certain amount of time to upgrade Kubernetes. So I'll be alt-tabbing and showing you other things as things are happening in the background. So hope that's okay with everybody. Here we have a Portainer instance. Portainer itself runs as a container inside your own network. It's not a SaaS service. It just runs as a container somewhere in the environment. In this case, it is running on a single server that happens to be running Docker. So this local one here is what's running the Portainer server. I have two previously configured Talos environments that are running through Omni, and I have a DigitalOcean environment. Again, Portainer is a universal multi-cluster manager, so we don't care what it is. We can run them all and manage them all from the one place. And here I have an Omni instance. I have a bunch of machines in there. I have some clusters in there. But basically, this is the environment as a starting point. I have already pre-configured credentials for Omni, so I've already defined the Omni URL and my credentials for that URL location. This can be cloud or on-prem, doesn't matter, as long as it's Omni, because we are talking to the Omni APIs, and we are sending the Omni configuration files to it to be deployed. From here, we have the ability to come into Portainer and we define environments. Now, environments for us are clusters. I would love to use the term cluster, except we have some people who use standalone Docker still, so we call it environments, but really it means cluster or clusters. And here you can attach existing environments that are already out there in your network, or you can provision cloud environments, or you can actually go and create an on-prem cluster. So in this case, we're going to create a cluster, and we have an Omni Talos option here available, where we can go and create a Talos Kubernetes cluster powered by Omni. And so we can give it a name, TalosCon. I'll just use demo envi, why not? We choose the credentials. So for this credentials here would be for the Omni URL and my service account, whichever I need to use. And now we choose the Talos version that we want to deploy and the Kubernetes version that we want to deploy. And I'm purposely using old ones here so I can upgrade and show you. And this is a live API call to Omni to give me this list. So whenever Omni updates, the list updates. And then we can go and see our machines. Now you have to have already booted off the Talos ISO and have machines registered again in Omni waiting to be configured. But you can now go and see, and this is from this list of machines here, we are basically pulling the machines that are available, not yet assigned to a cluster. And I can say for the control plane, I want to go and add one control plane, and I want to have 2 workers. If I need to, I can actually say I want to make a configuration change and I want to adjust the networking for this particular node. In this case, I'm not going to. And at this point, we just hit provision, and this will go and actually create me a 3-node cluster. Now, you will see here it's going to be provisioning. In the background, you'll see under clusters, the Talos demo environment is going to be coming up and configuring. So again, we are talking to the Omni API. The form, or this page here that I just completed, is actually creating the Talos configuration YAML behind the scenes and then submitting that to Omni and saying provision this. So it will let me actually have a fully configured cluster. So this is going to go off and build. It takes a relatively short amount of time to build, but this will go and build this cluster, and when it's done, we'll see and we'll be able to manage this environment. Now that's not the end of the demo, by the way, because that would be far too short. And so here we're basically just going through, and it's going to build a control plane, build the workers. But in parallel, what I'll show you is even when we have a functioning environment, so let's say that one is already built, we can come into another Talos environment here. You can see the the cluster nodes in here. You can get the cluster machine logs from here. You can upgrade the Talos version, update the Kubernetes version. You can see the resources that are being consumed in the cluster. You can see all of the namespaces that are running in the cluster, what namespaces are there, what applications are running. It's just a very, very quick and easy way to actually discover and interface with your Kubernetes environment. There's actually nothing here, so I'll just do the system so we can see system. So you can actually see all the applications that are running in the environment. You can see what it is, a pod, a daemon set, a deployment. You can come into it and you can see, well, here's core DNS. You know, are there any events from it that I need to be concerned about? No, there's not. Are there any logs? So you can really interface with it and see the logs of the pod logs. It's just really making the whole interaction with the cluster really simple. You can even do things as coming in and consoling in, should you need to. Well, that one doesn't have one, but so you can actually interface with the pods and just manage and triage your application. So this is just a really, really simple way of interfacing with the cluster. Is that one done yet? Almost. I'll just wait for it. Again, Portainer's main goal in life is to really simplify the use and operations of the platform. You know, the goal is that anybody in IT who has a sysadmin background should in fact be able to interface with, manage, operate a Kubernetes environment or a Docker environment. It shouldn't need experts to operate it. If it needs experts to operate technology, the technology will be held back. The adoption will be held back. So we're really focused around making it significantly easier to interact with and manage and consume. There you go, that's done now. So you can see its IP address and it's up. Now I can go back to the home page and we will see there is the new environment. We can see it's running, the API is ready. So I can come into this cluster and see the 3 nodes, the control plane and the other 2 nodes that I've added in here. And I can start to interact with it. I could immediately start to deploy applications. But let's say I want to make some changes to this cluster. It's a month later, load's getting up. I can say I actually want to add a node and I want to add another worker. So I'm going to actually add this worker to it, add node. And within a few minutes, or actually not even a few seconds, a new node will become available, will be added to the cluster. You'll already see it in Omni coming online. So this node is already booting and coming online. And yeah, Portainer will in very quick succession show you the 4th node and it'll be operational. So from a kind of day 2 scaling opportunity, it's quite simple to interact with the cluster. I am not going to do the Kubernetes upgrade just yet, but I might kick it off and then show you something else. Wait for this node. Come on. There we go. There's the other node of the cluster already added and live and ready. But let's say that we do actually want to kick off a Kubernetes upgrade. You could do this from Portainer too. You can say, hey, look, I'm running this version of Kubernetes. I want to go to 1.30.5, upgrade the version, confirm, and this will, behind the scenes, kick off a full upgrade of that cluster. Now I'll get out of that, and you'll see this thing will eventually come not ready, and it will start to go through and do a rolling upgrade. And this is fundamentally doing the same as if I came into this Talos environment here, and I actually went in and did a cluster upgrade. So I can come into this cluster example and say, yeah, update Kubernetes. We're just basically doing the same thing behind the scenes. So this will kick off. In the meantime, though, what I will show you is how easy it is to actually use Portainer to go and deploy your applications. So we've got the build of a cluster, the data operations of a cluster relatively well constrained. We know what we're doing. We can build a cluster. We can maintain the cluster. But then we can do things like, well, actually, now I want to come in and start to assign users access to this cluster. So you can see here I'm logged in as an admin user into Portainer. But because Portainer is a management platform, users interact with the underlying Kubernetes environment through Portainer. So you can configure Portainer to authenticate users from anywhere. So Portainer in this regards acts as the authentication layer for Kubernetes. So you don't need to install any OIDC provider in the cluster. We take care of authenticating the users, and we create a shadow user account in each cluster, which will then link to the actual user's account. So we take care of creating users and propagating users and maintaining users as users are churned out of the business or they change roles and their access is revoked. We revoke access in the cluster as well. But also, more importantly, we also have roles in Portainer as well. And so when you say, I want to give a user or a group, a team, access to a cluster, you also say, I want to give them access to a cluster with this role. And what we're doing here is actually creating a role and role binding in Kubernetes automatically for you. So you don't need to know how do I write Kubernetes RBAC rules. You don't need to know how to do that. Portainer does all that for you. One of the biggest challenges in Kubernetes is actually correctly configuring RBAC. The amount of people who do that wrong don't know they've done it wrong and end up having a vulnerable system. So we have a bunch of predefined roles, and you can come in quite simply and say, for this particular environment, this environment here, number one, this user or a group of users, like the operator user can have the operator role, create access, and we have now created a shadow user account in that cluster and given them a role and role binding assignment. So then when that operator user logs in, they'll be able to see that environment and interact with that environment. Now if I log out, I can just see that one environment that I've been given access to. And when I come into that environment, I'm an operator, so operator lets me interact with any existing running application, but I cannot create new applications, and I cannot delete or damage any existing applications. So I'm there to operate what's running. I'm not there to create or do anything else. So I can see any running applications. I can see the namespaces I have access to, but I can't delete them. I can't create new namespaces. I'm restricted in my access. And all of this is being done with Kubernetes roles and role bindings behind the scenes. So even if I was to bring up a kubectl shell in that cluster, I'm running this as that user with that user's RBAC role in the cluster. So it's just a really simple way of interfacing with it. Now let me just log back into the admin. So once we have a running environment here, you can choose to define what users can and cannot do. So you may have a load balancer. You can say allow or disallow use of load balancers. You can say who can actually configure ingresses and ingress controllers. Don't allow overcommitting the cluster. There's no cluster auto scaling, so don't allow users to ask for more than what's in the cluster. If there were storage options, you could see which storage classes can you use, what quotas can you define. So we can start to define rules. We can come in here and say, actually, this is a high secure cluster, so we want to turn on security constraints. And here we auto-deploy OPA Gatekeeper in the cluster, and we're applying OPA Gatekeeper policies in the cluster. So you don't need to know how to write OPA Gatekeeper policies, we just turn it on for you. So the whole thing is made really, really simple. Even something as simple as creating a namespace with quotas actually isn't as easy as you might think. So this one is a little easier because there's no storage and no load balancer, but if I switch maybe to the DigitalOcean one, yeah. And our load balancer and storage is on. So I can actually say, yeah, for this namespace, I actually want to have resource assignment. I want X amount of memory, X amount of CPU. You can only actually ask for 2 load balancers in this namespace. You can't ask for any more. You can only use these registries if you have any registries defined, and you can have storage, and you can use one terabyte of storage. That's all. So even something as simple as creating this quota without doing Portainer would be quite challenging. Do any of you guys know how you'd create a quota for a namespace with a load balancer quota and storage quota? It's not a simple thing to do. So we try to make really complicated tasks click simple. So really simplifying the whole day two operations and configuration of the environment. How is that environment going? Looks like it might be done. We'll go back here. No, still coming up. So this was, you see, it was at 1.30.0, and it should, in theory, come up to 1.30.5 in due course once it's finished doing its booting and everything else. But let me just quickly get out of this one. So here we have, again, an Omni environment, and let's say that I want to deploy an application. You can, as I said, choose your own adventure. So if you're not that competent with writing manifest files, you can actually use our form here, and this will let you deploy applications without needing to know how to write YAML files. We will create the YAML file behind the scenes here, so we're doing a daemon set or a replica set, or if you have persistence on, we'll do a stateful set. So we're creating all this for you. So you go and create the application deployment. But if you actually want to use GitOps paradigms, you can say create from manifest and link it to a Git repo. So I can say actually go and deploy this application. So I'll just go grab this one. So put in the URL, and so here this is kube. So I'm just going to do the MQTT broker. So you can say deploy this application. If you have multiple YAMLs, so you've got a multi-part, you can just actually add more and more of them. You say GitOps updates, a 5-minute reconciliation loop. Always apply manifest means don't allow people to make changes locally. So if someone makes a change locally, override it in the next reconciliation loop and hit deploy. Now this will go and actually deploy in this cluster. It'll create a namespace called Mosquito, which is already done. It'll grab the YAML and it'll deploy it in Portainer, and any changes I make in here within 5 minutes would actually be propagated into the cluster. So it's pretty easy to set up a GitOps pipeline from here as well. So it's already running here. So you don't need to go and set up Argo CD or Flux or worry about how you maintain this. It's all just done in one place. Portainer itself is also the GitOps engine, so there's actually no footprint in any of the clusters. So there's no agent, no GitOps agent in the cluster. Portainer itself, the Portainer server, is the one doing the reconciliation loop, looking for changes, and when it sees changes, it propagates the change to the remote environment. So the whole thing is centrally controlled and managed from within the one Portainer instance. Okay, so we actually have a specific capability. If I go into Portainer here, I can turn on edge compute features. And when I turn on edge compute features, there is an agent that we have in Portainer, which is a reverse connection. So at this moment, this is Portainer out, and it assumes that it has real-time instant access to the environments at all times. If you use our edge compute features, it's outside in, and it's basically a command queue. So the Portainer server is doing the reconciliation loop. It's seeing it as a change. It raises a flag that says, hey, endpoint 7, there's a change for you, and the next time it polls in, which is every few seconds, it sees the change, reconciles, and deploys itself. So you don't need any additional tooling here. You've got integration with metrics server, so you can see the CPU utilization. So the whole thing is simply a turnkey environment where the one tool to simply build and manage everything inside Portainer. Now, is that up now? It is up, and it's already at 1.30.5. So that cluster upgrade has completed. All 4 nodes are now running 1.30.5. Again, we could actually upgrade the Talos version. I won't do it, it's too long, but you could do the same thing and upgrade the Talos version to the latest version, and then I could actually upgrade Kubernetes to 1.31 if I wanted to as well, but you're able to basically interface with, and again, I can even go in here, node remove, and this will actually destroy it from a Omni perspective too. So this will remove the node from the cluster and destroy it and take it offline, ready to be reprovisioned. So really simple way to interface with the creation of environments. Now this is alpha code. We plan to release this in time for KubeCon, so around November. We have already decided now that because we are fundamentally through this process of creating this cluster, we are basically creating a YAML file at the end of this process here. We're actually going to allow you to not only direct provision, but to actually upload that to a Git repo and then actually have the cluster configuration also in a Git reconciliation loop. So you could then in fact go to the Git repo, make changes to it, and then the cluster itself will reconcile. So we're going to do that as well, just to give you something a little bit more, as code. So that's the Talos integration there. So I'm quite excited by this, because this is a complete sort of end-to-end turnkey solution now. You can those 4 servers are out there in the ether somewhere. They're connected and booting off an ISO file. Didn't have to do anything. We were just able to connect to them and say boot from the ISO, and I'm able to bring them online completely from within Portainer. No command line. I haven't jumped to the command line here. I can go and actually in this cluster now. I can even come in here and say actually go and turn on OPA Gatekeeper on this environment. Go for it. No policies, but I could go and turn it on, and let's see if it's actually going to work. Good luck on an alpha build. Let's see. But we'll deploy OPA Gatekeeper in the cluster, and again, it's just really easy to build and operate the environment. Yeah, it worked perfectly. Look at that. And so now if I come back to the applications, eventually you'll see another namespace, all namespaces. So you've already got it, Gatekeeper system namespace. So Gatekeeper's already running now. There's no policies applied. We just deployed it. We haven't applied any policies. But this is now running in the environment. So, from within this one piece of software, you've got the ability to basically do OPA Gatekeeper. You've got the ability to do Argo CD and Flux replacement. So you can do your own GitOps reconciliation. You've got the ability to spin up clusters. You've got RBAC and access control and authorization all built in. So you're really starting to get this platform tooling where it's just the one thing that you do there. There's not really any need for additional tooling. Portainer is just this one-stop shop that you need to do it. Now, one of the other really interesting pieces here is Portainer is actually a complete kube API proxy as well. So I can actually hit the kube config file here and download it, and it will give me a consolidated kube config file. And if I do this, you'll see all of the clusters. Come on. All of the clusters here are, don't save. All the clusters here are talking to the Portainer server as their actual URL path. And the credentials it's using happens to be the Portainer shadow user. So the shadow user that's in the environment. And it's the credentials for that shadow user. So this happens to be the shadow user name for my admin user account, and this is the credentials for that admin account. And of course, as the admin, I have access to everything, so I have all the clusters. So and now I could actually in my machine do kubectl. I could open up OpenLens or anything else that I wanted on my machine, and I'm able to access and manage those clusters through Portainer as a proxy. So you don't actually even need to open up any of your kube API ports to the internet, which is dangerous. If these were edge environments and they were on the other end of a 4G connection with carrier grade NAT behind them, no inbound ports, because of the edge agent architecture, you can still proxy through Portainer. The edge agent will establish a connection and actually get the same command queues. So I'm able to use my local environment through the Portainer proxy out to these clusters no matter where they are anywhere. So interesting little demo of what is to come. We want a lot of people to get hands-on with this version before we release it. So we'll be going out to beta for this Talos integration probably next month. So if anyone is actually quite keen to get some hands-on time with Portainer managing Talos through Omni, by all means reach out and we can provide you early access to it. But it is a really, really simple way to deploy and manage your Kubernetes environments. Yeah, all from the one place. Just out of interest, does anyone know about Portainer's capability in Kubernetes, or was this all new to you that we were even a Kubernetes tool? Knew about it? Yeah.
I knew you had some capability to connect to existing clusters, but I didn't know that you were like looking into the provisioning.
Yeah. I'll actually. This is going to be a bit slow because this one truly is in New Zealand. But just to show you the true scope of Portainer's management capability here. Come on. So this is a Portainer instance, and as you can see here, micro K8s, K3s, Docker, Swarm, Talos, Rancher, some edge environments, OpenShift, EKS Anywhere, K0s, Talos, and ACI. So it truly is a universal management tool. It doesn't actually matter what you're running, where you're running it, how you're running it. Even ACI, I can come in here to Azure ACI, and I can actually come and see the actual container instances that are running inside this ACI subscription. So it truly is a universal management tool. If you need to manage a vast array of environments anywhere and everywhere, and you want to centrally control and manage these things, apply policies, provide single centralized access control. This is the really simple way to do so. So just a really nice management tool. You can see these edge environments, just since you asked. The difference between edge and normal, you see up versus heartbeat. If I click an edge environment to manage, it takes a few seconds because it has to actually establish a remote connection back to Portainer. Now it's established a connection, I can actually manage it even though I have no inbound access to it whatsoever. So it's actually seeing that, hey, an admin is wanting to manage you, establish a reverse connection, and then I can actually go and manage this environment from Portainer regardless of where it's actually deployed. So just a really, really nice, easy way of managing stuff. Inside Portainer as well, obviously there's I'm not going to walk through every single feature because I'll bore you, but the main focus is on this policy and control. But we've also really focused on making Portainer a platform. So as I'm clicking around here, all I'm doing is calling our backend APIs. So everything that I'm doing in the front end here, you can also completely automate through our own API calls. And we also now have many customers who are building platforms on top of Portainer. So they've got their own internal IDPs or whatever else, and they're using our APIs to basically interact with and manage, so they don't have to worry about trying to go and replicate what we're building with Portainer. They're able to just simply consume our APIs and have their own interface or their own UI that is for their own purpose. Any questions so far? No?
Regarding the GitOps,
Mm-hmm.
yeah, absolutely.
Yeah, so regarding the GitOps functionality, are you adding any custom resources like Argo has the applications and application sets and so on, or are you just working with straight raw normal resources?
Straight raw normal resources.
Yeah.
So you can actually have it's simply a YAML file, and very soon it'll also be a Helm chart. But you can deploy anything with it. So if you want to have a CRD or anything else that's in a manifest, we will keep that in sync. In fact, I could come into here now and say I'll just go into this MQTT while we're talking here, and I can make a change. The replicas equals 2, and I'm not signed in. Okay, I won't do that. But yeah, it's simply just doing a reconciliation loop. It is looking at the actual commit ID. So you'll be able to, it's looking at the commit ID and saying, is the actual commit ID different from what I'm running? If the commit ID is different, it'll go and fetch it and then apply the change version. So there's nothing running at all in the clusters. It's all running natively in Portainer.
Thanks.
Other questions? You can see here, it says this application was from this repo, and the current version deployed is this version, and that's the commit ID for that one.
for bare metal clusters, how is it managing things like load balancers?
How's
So for provisioning IPs for load balancers and the like.
So we are simply talking to the Kubernetes API. And so as long as there is a load balancer defined in the cluster, so if you have metal LB or something else, as long as you have that in the cluster, you're all good. And so we simply ask Kubernetes, hey, deploy a service of service type load balancer, and then Kubernetes takes care of that. Talos itself doesn't have any load balancers by default, so you have to go and deploy a metal LB or something else on top of that. And something's happened to this one. Hope I've been kicked off. Oops. Got Cloudflare in front of it. No, there we go. Got other questions? If you haven't seen Portainer and you don't understand what it is, feel free to ask while I'm here. Otherwise, that's all I wanted to show you. So, again, idea, Talos's goal is to simplify the creation of Kubernetes clusters. Our goal is to simplify the configuration and consumption of Kubernetes clusters, end-to-end simplified environment. That's the net goal or net intent of this. Make sense? Useful? Even for those who don't like ClickOps? Yeah, you can actually come into settings as the admin, and you can actually say, hey, look, I actually I want to do enforced code-based deployment, and then we can say, so this is globally, or you can actually say, I actually want to have a per environment, and so for this environment, non-prod, you can have the form wizard, but for all other environments off, or you can simply say, actually, I don't want it off. I don't want anyone to use the forms. I want it completely code-based. So again, it's pick your own adventure unless the admin says otherwise. There's a bunch of stuff as well, like disabling kubectl access. We also let you hide the secrets. So Kubernetes secrets are not that secret. As long as you have access to a namespace, you can see it. Because Portainer sits in between, if an admin turns it on, we actually will not allow a user to view the contents of a secret. So you can just flick a switch, and we will stop them from being able to see it, which is quite a useful feature when you don't want users being able to view it, especially when you've got image pool secrets held in there, and you may not want users knowing the credentials for the actual registry. So you can turn that off as well. Otherwise, that's it. And it worked in alpha code live. Need to delete my application now. I want MQTT running live on the internet.